Okay, we're going to try working on creating a double buffer Java example. This is going to be a windowed object, windowed class. It's going to actually show a window on the screen. It'll be called double buffer. It extends the frame class. The frame class is the abstract windowing toolkits. Frame class, a window class in Java, implements the runnable interface. The runnable interface is so we can use threads. And the main method, we're going to just create a new double buffer object, set its, that is the window, set its size, add the window listener connection so that it will handle window closing events correctly, set the title of the window, make it visible, and then call a method we're going to call drawGraphics. This drawGraphics method is going to create an image object behind the scenes. That image object will be our double buffer. That is where we're going to handle the actual drawing of the image we're going to put on the screen. We're going to handle it in the image object and then display it on the screen when it's all drawn. So then we're going to also get a graphics object. Graphics objects in Java let you draw in images. So we're going to get a graphics object, and then now we're ready to draw in that background image, and then start a new thread. This new thread will run in the method called run, and while true means just loop forever, repaint. Just keep repainting whatever is on the screen. That repaint call makes Java call the paint method of the window. And then we're going to put the thread to sleep for 100 milliseconds. So it's going to sleep for a tenth of a second, and then it's going to call the repaint method again. So this just continually redraws the screen. So now what we've done is we've set up a double buffer window, a window called double buffer of the double buffer class, and we have made it repaint itself every tenth of a second, and that the real action takes place in the paint method. In this method, which is called repeatedly by our program, we're going to check whether or not the graphics object that gives us graphics access to the image, to the double buffer object named image, is not equal to null. If it's not equal to null, we're going to increment this loop index by 4. If loop index is greater than 100, reset it back to 4. So this loop index is going to hold a value of 4, 8, 12, 16, and so forth all the way up. And we're going to use this to draw rectangles off screen and then flash them into the actual graphics object for the actual window. Now, as you recall, the graphics object for the background image is called graphics. The graphics object for the actual window is called G. So please don't get those confused. And we're now going to draw in the background double buffer object, the image object. And that's using the graphics object. You get access to that with the graphics object. You say graphics.setColor. It sets the new drawing color to white. Fill rect, and it fills a rectangle. It blanks the whole image, and then you set the color to a new color, which is a shade of red based on the loop index value. And then you draw a rectangle. So this is going to draw a new rectangle using this red color, and what we're going to see then is a gradually growing set of rectangles appearing and then resetting themselves in the window. And then after this is done, now remember, this graphics object gives us access to the double buffered image, and the double buffered image is going to have a new rectangle drawn in it using these commands. And then we're going to draw the image from the image object to the window. The window uses a graphic object called G. This graphics object corresponds to the image, background double buffer image, and we're going to then draw from that image into the actual window using this command, g.drawImage. Draws from the image into the graphics object of the actual window. So there you go. That shows you how to work with double buffering. We just have a run method that keeps running and repainting the window. And in the paint method, which is called repeatedly every time you repaint the window, you're going to reset a loop index value, add 4 to separate our rectangles by 4 pixels as they're drawn, and then draw a new rectangle in a varying color of red, and then I'm going to actually draw the rectangle like this, and then we're going to, after having prepared the image object, we're going to draw the image object using the draw image method of the graphics object, draw it in the actual window. There you have the full double buffer example. We'll take a look at how it works now, and we're going to run the double buffer Java class. Right now it's going to launch a window, and you should see a number of gradually increasing rectangles, and it should reset itself as when the loop index gets to its maximum value. So here you go. There you are. See, it's working as it should. Those increasingly red rectangles are being drawn off screen and then being drawn in the double buffer, and then being placed in the actual window itself only after the image is ready to be moved to the image of the window itself. So there you have a double buffer example. The program draws its graphics off screen in a image buffer and then displays that image buffer on screen as you see there. So that is the double buffer design pattern at work.